We are in Chapter 2, Section 1, called Writing Equations. This is for IM1 or Integrated Math 1. So just to review the features here that you see on the page, this is the start screen that you will see as a student on ALEKS, with the exception of a couple of things. You will see a due date here. I don't see that on the teacher preview, but you'll definitely see it here before the attempts. This shows you that I am on attempt number 1 of unlimited attempts. This means I can come in and do this as many times as I would like. So you are not limited on that. This tells you how many questions you have in this particular assignment. So it's anywhere from 1 to 10. So we have 8 on this one. You get your best score for the grading policy. So whichever attempt is your best score is the one you keep. You get partial credit also. So if you do 1 of 8 questions, you get credit for the 1 question. This is just a reminder down here. Always click the Submit Assignment button. So on the next page, when we click Start, you will see a Submit Assignment button down here. I don't see it because it is not on the teacher preview page. But on your page, you will see a Submit Assignment button. Always click that button when you're done, whether or not you've answered all the questions. If you've only answered number 1, that's fine. Click the Submit Assignment button and you can come back and try again later. That way we know that you've tried it, you get a grade on it, and it won't lock you out of all of your other assignments. If you don't click the Submit Assignment button and you just leave, so you close the tab or you click the Home menu button that's up in the top left corner on the student screen, it's going to lock you out of everything. You won't be able to do topics or quiz or tests or anything until you come back to this assignment. So it's very important you click that button. Over here we have the explanation. So this will actually explain the problem you are looking at currently. So you will lose your question attempt. It's not going to give you the answer and then let you come type the answer in. But it is a nice feature. Maybe you have looked at the example and you're still not sure exactly how to do this problem type. Maybe it's a little different than the example. You can actually look at the explanation and then you'll just have to come back in on another attempt to actually answer the question. Example just gives you a general example of the problem type. Again, very, very helpful. It goes through and it'll give you any background information you need if there's anything. And then it explains to you what it wants you to do. If you need more than one example, just simply click again. It'll give you a new example. And then there's the message center. So you can send a message directly to your teacher using this button with this question attached. So we know where to help you. All right. Let's go ahead and get started on this one. So this says translate the sentence into an equation. And we've practiced this already. We practiced it in Chapter 1 when we're translating from a verbal to an algebraic. And in the first chapter, it was verbal expressions to algebraic expressions. Now it's going to be verbal equations to algebraic equations. So the difference is there's an equal sign now. That's the difference between expression and equation. We just need to know the key words. And there's definitely a website that I have linked on ALEKS so that you can go and review those keywords. If you are having trouble identifying them, it's something that you most definitely want to kind of study there so that you know what all of the words mean when you hear them. Because otherwise you're going to have a difficult time with this concept. So when we're looking at this, it says the product. Right away, I know the product, that means multiplication. I'm going to be multiplying the next pieces I hear. So the product of Maya's score and 4. So those are my next 2 pieces. Those are the things I'm multiplying. Is 68. And then they tell me to use M to represent Maya's score. So I need to make sure I don't get to just use whatever I want. I have to use M. So it's Maya's score and 4. I don't want to type it in this way. This technically means multiplication, but we want to type it in as 4m. You can also use this here, but this means multiplication when you just smush them together. Anytime I hear the word is in a word problem or any kind of problem like this, it means equals. That is my equals word. So they're either going to say is or equals. Sometimes they go is the same as, which is just overkill for the word is. And then we go 68. They are not asking me to solve this question. They just wanted me to write the equation. So I can click check and I'm good to go. If you'd use this little times button, perfectly fine. It would have still given you the same thing for this. It's just a little bit more expanded out there. All right, so we have translate the sentence into an equation. So same thing. Now we're looking at a little bit more steps here. So twice the difference of a number and 5 equals 3. So twice, that's a multiplication word. That tells me I'm multiplying by 2. So I know it's going to be 2. I'm going to be multiplying by that number. The difference of. So that's another one. That's a key word. I know that I'm going to be subtracting the next values. But specifically, I know that I'm going to be grouping these also because I'm multiplying that whole difference by 2. So I need to make sure that I use parentheses on this one. And it's the difference of a number and 5. So if I hear a number, well, okay, it's a number, I don't know what it is. That means it's a variable. And if I read this third sentence here, it says use the variable b for the unknown number. Okay, so it's a number, which I just was told is, I'm going to represent that with b, and I'm subtracting the difference of b and 5. And then they say equals, so that's pretty easy. We're going to use the equal sign, and 3. So again, I'm using my keypad. That's why you don't see my mouse coming over here and clicking. But you can use your keypad to hit the equal sign, to hit the plus sign, the minus sign. You know, even creating a fraction, you can hit the backslash. But you can also just click on these buttons here, and it'll insert these pieces for you. All right. So we're going to keep moving along here. Pablo bought N packs of pencils. So we don't know how many packs of pencils he bought, but we do know he bought a certain number of packs of pencils, and they're representing that with N. Each pack has 12 pencils in it. Each is a multiplication word. Write an equation to represent the total number of pencils, P, that Pablo bought. So if he has N pencils in a pack and there's 12 there, I don't want to go N12 because we always put the coefficient first. But if there's 12 in each pack, that means if he bought one pack, he has 12 pencils. If he bought 2 packs, he has 24 pencils because I'd multiply those together. So 3 packs, I'd multiply by 12 and I'd get 36. So this represents the number of pencils he has, and they want us to specifically say equals P. They told us that P is the number of pencils he has. So 12 times the number of packs he bought tells us how many pencils he has. Again, more practice with those key words. If we don't know those key words, you definitely need to you can do flashcards. You can, just make sure you're reading through the definitions, doing some kind of memorization. But you want to have those memorized to make this a little simpler, so you're not struggling to figure out what all of these words mean as we get to more complicated problems. All right. Each equation below is followed by several stories. Select all the stories that can be represented by the equation. If none of the stories can be represented, select none of the above. All right, so we're given this equation here. It says 8x equals 56. So this is 8 of something. This is going to be multiplication. I'm going to need to hear the words each, or every, or per, something along those lines. Well, per would be division, so we don't want to necessarily use per. But we want to hear some kind of multiplication word here. I want to hear is or equals 56, or total of, would also be another one that they could use there, depending on, but usually they use the word is or equals. We'll go ahead and see in here because this is kind of written a little differently than the previous ones, seeing as we're picking the story. So a box had X pencils in it. Okay, so this would be a box, and we have X pencils. Then 8 more pencils were placed in the box. Well, if 8 more pencils were placed, then that would just be however many pencils are in the box, which is X, plus 8 more. We wouldn't be multiplying those two pieces together. So that one doesn't work for this equation. A box had X pencils. All right, so we have X pencils again in the box. We don't know how many. Then 8 pencils were removed from the box. Okay, well, that means I'm taking away from them. I'm removing them, which means subtraction. So that one doesn't work. A box had 8 pencils in it. Each pencil weighs X grams. Okay, so I have 8 pencils, And I have my word each. Now we're talking about weight. So we have X grams. The 8 pencils weigh a combined total of 56 grams. So they are using that total idea. So a combined total would be, our equals. Normally we hear the word is or equals, but this one also works. If we hear, total of, that tells us that that's also an equal sign. So this guy does work because that is multiplication. A box has 56 pencils. Okay, maybe that's our total. The pencils are aligned in 8 rows with X pencils in each row. Okay, well now I have 8 in each row. Each row has X pencils in it. So this is a multiplication issue. That does work. That one works for this scenario. All right, now we have X minus 7 equals 35. So I have something, and I'm going to be taking 7 away from it. And my total will be 35. So there are X dogs at a park. Then 7 dogs were taken away. All right, that works. Taken away, that's a subtraction. So I started with X dogs. 7 of them were taken away. Now there are 35 dogs. That works. A dog park has 7 sections. Each section has X dogs. Each is a multiplication word. So that one, I'm not multiplying in this one. I don't want a multiplication word in there. There were 7 dogs at a park. Then X of the dogs ran outside of the park. Well, this would mean that I would have 7 and I would take X of them away. So this is kind of backwards. We need to make sure we're reading it in the right order for this one. We can't flip-flop the 7 and the X. And then the bottom one, the combined number of dogs at a park is 35. Okay, that's still a total. There are X small dogs and 7 large dogs. Well, this would mean that we're probably adding these together. If there's this many small dogs and this many large dogs, this isn't talking about any kind of subtraction. Combined number, though, tells me there's probably going to be some kind of addition. I'm putting them together. So this should be it for that second one. Let's see what we get. Perfect. Okay. Dion sold t-shirts and hats at a festival. His total profit was $168. He made a $6 profit for each t-shirt he sold. He also made a profit of $54 from selling hats. How many t-shirts did he sell? All right, so this is a little bit more information, and it's kind of scaffolded out a little bit. We first need to choose which is the correct format. Am I adding something? Am I subtracting something? So we know we're going to be multiplying. That's what this X is next to a coefficient. But then we need to decide, am I adding the next piece or am I subtracting it? We need to write out our equation. And then we're going to plug it in. We're going to solve it. So, not plug it in, sorry. We're going to solve it so that we figure out how many t-shirts that he sold. So let's break this problem down a little bit. So we know that he sold hats and t-shirts at the festival. So those are our 2 pieces here. So his total profit was $168. That's the total amount of money he made. He made $6 profit for each t-shirt. Okay, so each is a multiplication word. So he made $6 for each t-shirt, and they tell us actually down here in this part, so write an equation that could be used to answer the question above. First, choose the appropriate form, then fill in the blanks with the numbers 168, 6, and 54. Let X represent the number of t-shirts. So they tell us to let X represent the number of t-shirts. So it's $6 for each t-shirt. There we go, 6X. He also made a profit of $54 on hats. So they're not doing each there, they're just saying that's another $54 that he made. So here is our equation, kind of breaking that down. And I wrote it in pieces there. But that tells me I'm going to write in this first one here. So I'm going to have 6, 54, and 168. And now we want to solve it to see how much did he actually sell, how many t-shirts. So first we need to undo some of this. Well, if this is the amount of money he made for hats, we need to take that away from both sides because I want to know what was his profit on just t-shirts. 6x comes down. These guys cancel. And I'm going to subtract, and I have 114. So this is how much he made on just t-shirts. Well, if they're $6 each, I want to divide by 6 so I know how many t-shirts were in here. So x equals, so let's see, we'd have 1. I'm being a little lazy there. I'm using a calculator. But you can definitely write this out and use kind of long division for this. But in this case, it would be 19 t-shirts. All right. So it looks like we're kind of coming back over the screen. Select all the stories that can be represented by the equation. If none of the stories can be represented, select none of the above. So let's think about this equation before we start reading. We have 26 of something. We should hear an each in this scenario. And then we're going to take 65 away, so 65 something, and then it looks like kind of glancing down, it's going to be money. And the total will be $273. Okay, and I'm saying dollars because in this situation for me, it looks like it's definitely talking about money. So today, Nicole used $65 of her savings to buy a bike. That's consistent. She used it, so it's going to be taken away. She has been putting $26 into her savings each week for X weeks. Ooh, I hear a multiplication word. There's 26 for each week, and they told us that's X. That works so far. After buying the bike, she now has $273 left in her savings. Okay, there's my total, so that works. Because I had a subtraction of 65, that she used the $65. She's been saving $26 per week or each week for X weeks. That's 26 times X, and my total is 273. All right, Nicole is saving money and already has $65 saved. Okay, well, this immediately is opposite of what's being said up here. 65 is being saved, that's being taken away. So I can stop right after that first sentence and go, nope, that does not work. I'm going to go to the next one. Nicole is saving money and she already has $65 saved. Well, again, that doesn't necessarily work, does it? Because this means that she'd be adding what she's saving per week to that 65. So let's go to the next one. Today, Nicole used $65 of her savings to buy a bike. All right, that's the same thing as kind of that first one you chose anyway. That works. That's taking $65 away. She has been putting X dollars into her savings account for 26 weeks. Okay, that still works, even though we switched that amount. This is now 26 weeks, and she's been putting in X dollars. But it's okay to flip-flop those meanings. It still means we're multiplying the two amounts. And now she has a total of $273 left. So that works as well. All right, let's look at the next one. So we have 32 of something. We should hear multiplication here. And then we should hear an addition of $16 and a total of $208. So a printing company charges X dollars per banner. There is also a one-time setup fee of $16. So far, this might sound like a minus, but if we're totaling a bill, this would be an add-on. So we would add 16 to the bill to do this. So this still works. Bravi printed 32 banners. Remember, it was X dollars per banner and $32 or 32 banners. So 32 times X, that works. He paid a total of $208, so that's the total. So perfect, that guy works. A printing company charges X dollars per banner. There is also a one-time setup fee of $32. Oh, well, this wouldn't be a one-time setup fee if we're multiplying it by the number of banners, or dollar per banner. The one-time setup fee would have to be the addition here. So that one doesn't work. A printing company charges $16 per banner. Okay, but this is per banner. That tells me multiplication, and that's not what this is saying. This is just adding 16 one time. So that one doesn't work either. A printing company charges $32 per banner. Okay, that's fine. $32 per banner. They haven't told us quite yet in the sentence that X is going to be the banner, but they will. There's also a one-time setup fee of $16. Okay, that's the one-time $16 add-on. And Ravi printed X banners. So this is the same one as the first one, but they did the same thing where they flip-flopped the money and the banners. But that's perfectly fine because we still have a total of 208. All right, 2 more questions here and we'll be all done with this section. This one's definitely a little bit longer here. On Friday, a local hamburger shop sold a combined total of 524 hamburgers and cheeseburgers. So I'm going to stop and go hamburgers and cheeseburgers. And together, we sold 524. So that's my first sentence. The number of cheeseburgers sold was 3 times the number of hamburgers sold. So the number of cheeseburgers was 3 times the number of hamburgers, right? So if I take the number of hamburgers and I multiply by 3, that's how many cheeseburgers were sold. How many hamburgers were sold on Friday? So remember, I know if I add H plus C, it's going to be 524. But I don't really want H and C in my equation. I can't really solve this. There's too many variables. So what I want to do is instead of C, I want to put in that 3H. Because I know the number of cheeseburgers sold was 3 times the amount of hamburgers. So I can go H plus 3H equals 524. So I just replaced. I substituted that in. Now I can go ahead and solve this because I have some like terms. I have 1H, remember there's a 1 there, plus 3, so it's 4H equals 524. And all I have to do here now is say, okay, well, I'm going to divide by 4. On both sides, this is multiplication, so I'm doing the opposite. So H equals, let's see, 524 divided by 4 is 131. So we sold 131 hamburgers. And if I tested that out and I said, okay, well, what's 131 times 3? This is the number of cheeseburgers I sold because I just take the 131 and I multiply by 3. So now if I add these back together, I get 4, 9, 10, 11, 12, 3, 4, 5. Look at that. We land back where we were supposed to, right? So that checked correctly. So this guy does work. 131 hamburgers. All right. Last one here. Definitely a little bit more involved. Questions on some of these. Lily, Ruben, and Juan sent a total of 103 texts during the weekend. So we have Lily, we have Ruben, and we have Juan. And together, they sent 103 texts. So I'm just kind of picturing that real quick. This is what the first sentence told me. Ruben sent 3 times, so that's 3 times as many messages as Juan. So we can also say that Ruben is the same as 3J. He sent 3 times as many as Juan. Lilia, I guess, sent 7 fewer messages than Juan. So we can say for her, we can take Juan's messages, and if we take 7 away, that's how many Lilia sent. So we have our pieces. They want to know how many messages did each send. So we're going to solve. We have to go through and we're going to have to solve for one of them and then go back and plug that in. So remember, if I go Lilia plus Ruben plus 1, it's 103 texts. But I don't want all 3 variables. So instead of Lilia, we're going to put this J minus 7. Instead of Ruben, we're going to put 3J. And then for Juan, we're just going to leave J alone, because that's what we kind of base the other 2 off of. So now all I have is a bunch of J's in here. So J plus 3J plus 1J. So remember, these are 1s. 1 plus 1 plus 3. All right, that's 5J. And then I have minus 7. So I was adding like terms there. Sorry, I didn't say that out loud. I'm adding the like terms, J, 3J, and just 1j. So now I've added like terms. I have no more simplification left to do. I need to solve this equation. So I'm going to add 7 to both sides because I always want to start with addition and subtraction. I'm subtracting 7. That's why we're adding 7 so that they cancel out. So I have 5j equals 110. Now I'm multiplying by 5, so I'm going to divide so that they cancel. And let's see, 1 cent. If we divide by 5, we get 22. So that's 1. Remember, Lilia sent 7 less than that, so I just need to go minus 7 because we already wrote that down. So she sent 15 texts. And then Reuben, he sent a whole lot here because he did 22 times 3, which is 66. And again, if we add these back together, we should land at 103. So let's see, if I have 5 plus 6, I get 11, plus 2 more is 13. And then 6 plus 1 is 7, plus 2 more is 9, plus 1 more is 10. All right, I kind of did that in my head. I know I did that out loud. I didn't really write it down, but that does get me back to 103. So that should be good to go there. All right, yay. That was section 1. I will see you in section 2.